In this section, we are going to talk about division algorithm for polynomial. We'll start with an example where we have a polynomial 2x squared plus 3x plus 1, and we'll divide this polynomial by x plus 2. When you try to divide it, this is how your division will look like. X plus 2 is your divisor, and 2x squared plus 3x plus 1 is your dividend. When I try to divide it, I'll first try to cancel the first term, which is 2x squared. In order to do this, I got to multiply x plus 2 with 2x. And what I'll get is 2x squared plus 4x. Now when I try to subtract this, 2x squared get cancelled. 3x minus 4x will give me minus x. And I will bring plus 1 down. Now I have to plan to cancel this. In order to do this, I'm going to multiply x plus 2 with minus 1, which will give me minus x minus 2. And now I'm going to subtract this. X and x will get cancelled. Minus 2 will become plus 2, and hence I'll get 3. At this point of time, I cannot move further. Why? Remember, we stop the division process when either remainder is 0, in this case remainder is not 0, or its degree is less than degree of the divisor. What is degree of your term which is left? 3. It's 0, right? And what is degree of your divisor? It's 1. And since degree of remainder is less than degree of divisor, so we will stop the process. So here the quotient is 2x minus 1 and the remainder is 3. We can represent 2x squared plus 3x plus 1 as x plus 2 multiplied to 2x minus 1 plus 3. X plus 2 is your divisor, 2x minus 1 is your quotient, and when you add remainder to this, what you get is dividend. Let's take another example where we will divide polynomial 3x cubed plus x squared plus 2x plus 5 by 1 plus 2x plus x squared. In this case, dividend 3x cubed plus x squared plus 2x plus 5, and the divisor is 1 plus 2x plus x squared. We are going to first arrange them in the ascending or descending order of the degree. And hence, divisor will be organized as x squared plus 2x plus 1. Dividend was already organized. Now we can perform division. And when you try to perform division, your division will look like this, right? So I have x squared plus 2x plus 1 as my divisor, 3x cubed plus x squared plus 2x plus 5 as my dividend. Now in order to cancel 3x cubed, I'm going to multiply x squared to 3x, and hence my first term in the quotient is 3x. And when I multiply 3x to x squared plus 2x plus 1, what I get is 3x cubed plus 6x squared plus 3x. And when I try to cancel this by doing subtraction, these two terms will get cancelled, and 6x squared in x will give you minus 5x squared, and 2x minus 3x will give you minus x, and will bring 5 down. Now I have to cancel this 5x minus 5x squared minus x plus 5. To do this, I'm going to multiply this to minus 5. And I'll get minus 5x squared minus 10x minus 5. When we try to cancel it, minus 5x squared plus 5 squared x squared will get cancelled, and this will give me plus 9x, and I'm also going to get 10. Now at this point of time, I'm going to stop. Why? Because degree in the leftover 9x plus 10 is less than degree of your divisor, which is x squared plus 2x plus 1. Here the degree is 1, and here the degree is 2. So here is your division algorithm now. If px and gx are any two polynomials with gx is not equal to 0, then we can find polynomials qx and rx such that px can be represented as zx multiplied to qx plus rx. In this case, it is something similar to dividend. Here px is dividend, gx is divisor, qx is quotient, and rx is remainder. Where either rx can be 0 or degree of rx will always be less than degree of zx. Now let's take an example again. So divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square and verify the division algorithm. Here we notice that both the polynomials are not organized, so I'm going to organize them in the descending order of their degree. Hence, dividend can be written as minus x cube plus 3x square minus 3x plus 5, and divisor can be represented as minus x square plus x minus 1. And now we are ready to perform division. And when you try to perform division in the similar pattern, I'll try to cancel it. And what I'll see at the end, I get 3 left over, which is going to be my remainder in this case, and whose degree is 0, which is less than the degree of your divisor. And hence we are going to stop here. Right, now let's try to verify. Divisor into quotient plus remainder will give you minus x square plus x minus 1 multiplied to x minus 2 plus 3. And when you try to simplify this, what you'll get is minus x cube plus 3x square minus 3x plus 5, which is nothing but your dividend, and hence verified. Let's take another example. Find all the zeros of 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2 if you know that two of its zeros are square root of 2 and minus square root of 2. Since the two zeros are square root of 2 and minus square root of 2, hence we know x minus square root of 2 and x plus square root of 2 are the factors of given polynomial. Now x minus square root of 2 multiplied to x plus square root of 2 is going to give you x square minus 2. Why? Because we know x minus y multiplied to x plus y is equal to x square minus y square. Now let us divide the given polynomial by x square minus 2. And when you try to divide it, in this case, if you try to go ahead and simplify this, what you will see, you finally get to a place where your remainder becomes 0. And hence, 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2 can be represented as x square minus 2 multiplied to 2x square minus 3x plus 1. And now by splitting minus 3x, we factorize 2x square minus 3x plus 1 as 2x minus 1 multiplied to x minus 1. And hence, additional zeros are x equal to